Hey, good morning, everybody. This is Mr. Aynesworth, and we're going to get into a little prep here for activity 2C1. So here we go. Let's talk about some basics on fractions here. And the whole idea about this one is about finding rational numbers between two given rational numbers, or two given fractions here. And the whole idea of this activity is to explore the concept of what's called density of the rational number set, or the real number set. So let's go over some basic facts here and some things that you need to know. So the first thing I want to explore and just review with you is what happens to the fraction size if you keep the numerator constant and increase the denominator. So what am I saying? So let's take a look at some fractions. So let's say 1/2 to 1/3 to 1/4, let's say, to 1/5. Just follow along with me here, to 1/6. That's good enough. So notice that the numerator here, okay, the numerator, that's the number in the top, okay, is constant. Okay, it's always 1. All right, so when the numerator is constant, what happens to the size of the fraction when you increase the denominator? Okay, this is called the denominator, as you guys already know from back in grade school. So when you increase the denominator, what happens to the size of the fraction? So to fully understand that, let's just draw some simple pictures, okay? So let's suppose we have a circle. Pretend that's a perfect circle here, and let's shade it in half. So that is a representation of what it means to be a half. Let's take a look at the fraction size of this when you draw them. So draw a circle, shade in 1 part out of 3. That represents 1/3, okay? 1/4 divided into 4 equal parts, shade in 1/4, 4/5. It's a little bit more challenging, but try to divide it into 4 or 5 equal parts. That's not good enough. It should be equal parts. That's a little bit better. There's 1 part out of 5, and then 6. Draw the Mercedes and then just divide them into 6, or bisect them. So here's 1 part out of 6. So notice that as you increase the size of the denominator, all right, the fraction size gets smaller, okay? Think pizza. If you take a pizza, let's say, and you divide it into 6 equal slices versus 5 versus 4 versus 3 versus 2, all right, the more slices you get, okay, so as the denominator here gets larger, or in a pizza, if you increase the number of slices, the size of the piece decreases. All right, so it should be pretty simple to notice that keeping the numerator constant, here's the key idea. All right, so keeping the numerator constant, okay, constant means it remains the same, constant, okay, that's the preface there, okay, as the denominator increases, I gotta spell that right. Denominator, sorry, increases. Okay, goes from 2 to 3 to 4 to 5 to 6. All right, so the denominator increases, goes up. All right, the size of the fraction decreases. All right, the overall size of the fraction decreases. So you have to know that basic fact. Think pizza, if you will. Okay. Key fact about fractions. If you keep the numerator constant and increase the denominator, you're going to get a smaller fraction. So in this case, we go from big, and it gets big to small. Okay? Now with that in mind, let's go through a couple methods here on how to find some rational numbers, fractional numbers, or any number that can be written as a fraction, okay, or a ratio of two integers, all right, between two given numbers, okay? So let me pose the problem here. So let's suppose that we are given two fractions, 5/7 and 5/6. Okay, so let's talk methods here. So method 1, that's an E right there. So method number 1. Okay, so given two fractions here, our goal is to find 3 fractions between the two given fractions. So find 3 rational numbers, basically. Okay, fractional numbers All right, between the two given fractions. Between the two given fractions. Rational numbers. Whatever. Okay, so here we go. First method. So let's suppose we have 5/7, and you want to find 3 rational numbers between 5/7 and 5/6. So notice that the numerator is constant. Okay, notice that. So let me just make a little note here. Okay, numerator is constant. Okay, so obviously, right here, 5 and 5. So how would you do this? How would you find 3 numbers that are between 5/7 and 5/6? Okay, knowing what you know about fractions. So you got to be thinking about that. How would you do that? Because these fractions do not have the same denominator. Okay, so if you are thinking about this right here, the first most common thing that people would do, perhaps, is to find a common denominator and then go from there. Okay, so let's do that. Let's find an LCD. So let's go off to the side here. Least common denominator of 7 and 6. So write the right number. So 7 times 6, 42. So when you find an LCD, you simply multiply the two denominators. That's the quickest way to find a common one. Not always the lowest one, but a quick way to find the common one there. And you want to convert. So 5/7. So 5/7, all right, times the other denominator there, 6/6, will give you 30 40-seconds. The other fraction is 5/6, so 5/6 times 7/7 will give you 35 40-seconds. And notice that we have common denominators now. All right, so the same question I posed to you is that, okay, so now we have 30 40-seconds, and we still have to find 3 fractions in between these two. Between 30 40-seconds, okay, and the other one, 35 40-seconds. So notice that we do not have the same denominators now. Okay, so now we have the same denominators because we converted. Okay, we converted to an LCD. So convert, all right, to have an LCD. So now we can compare numerators, which is a lot easier for most people because back in grade school when you first started learning the concept of fractions, you dealt with common denominators a lot, and you compare fractions by looking at their numerators. Obviously, 30 out of 42 is less than 35 out of 42. So we're going from small to big, all right? So this is smaller than this. So all you have to do is just adjust the numerator now. So now we're going to look at the numerator and increase the numerator, because as the numerator increases in the fraction, this fraction size gets bigger. Okay, so maybe 31 out of 42, and maybe 32 out of 42, which can be reduced because they're both even there, and maybe 33 out of 42. This is one possible set of numbers that you could choose that lie between these two given fractions. Okay, and then if you reduce this, like you guys were trained to do, divide them both by 2, you get 16 out of 21. The other two, they can reduce too. So this one you can divide by 3. So you get 11 14ths. Okay, so you reduce. 31's prime, so you can't reduce. Okay, so you reduce if possible. Okay, so my results that I found in this case is 31 40-seconds, 16 21st, and 11 14ths. Those are 3 fractions between the two given fractions. Okay, so this is one way you can do it. You can get an LCD, all right, and then just increase the numerator, from 30 to 31 to 32 to 33, and then of course to 35. So we're going from low to high, okay, because this is smaller than this. So in this case, we went from low, all right, to high. First basic idea. So that's what anybody that knows anything about fractions would do if you didn't know anything else about fractions. Just increase the size of the numerator and boom, there you have it. Okay? And what commonly is not known is the method of decimals. Okay, so let's take a look at a different approach. All right, using a little bit of number sense. So method 2. Okay, using decimals. So method 1 was converting to LCD. That was method 1. It was using an LCD. Let's highlight that over here. So method 1 was using an LCD approach. All right, method 2, using decimals. And it's surprising that a lot of people, have not seen this. So this is kind of a neat method here. It's actually quite simple once you see it. So using decimals. So same problem, but done entirely differently. So let's pose the problem again. So 5/7, and then our goal is to find 3 numbers between 5/7 and 5/6. But in this case, we're going to be using decimals. Okay. So now we're going to keep the numerator constant, and we're going to calculate, or we're going to create fractions. All right, that are between these two, 5/7 and 5/6, but by using decimals. So we're going to keep the numerator constant. Okay, so keep numerator constant. And vary the decimal, vary the size of the decimal. All right, so let's see here. So we pick decimals between 7 and 6. So let me highlight this. So we're going to focus in on the denominators. Okay, so here we go. So the first fraction here, we can say, okay, pick a decimal between 7 and 6, like 6.8, let's say. So 5 divided by 6.8. And again, we're keeping the numerator constant. So pick a decimal that's closer to 6, like 6.5. And then how about something between 6.5 and 6, like 6.2. So when you look at these denominators here, what's going on? So I'm changing the denominator now. And what happens here, if I decrease the size of the denominator, I increase the size of the fraction. Okay, that's opposite of what I said up here. If I increase the denominator, I decrease the size of the fraction. Well, if you go the other way, I'm talking about this way now, if you decrease the denominator, the fraction size gets bigger. Okay, so no big deal. All right, so now on this one here, we increased or decreased the denominator by using decimals, but these are not rational. Okay. That's not a rational number, not a rational number, okay, because it's not a ratio of 2 integers, okay? Rational form, if you guys remember from previously here, is equal to an integer divided by another integer. So I'll highlight that, okay? And obviously 6.2 is not an integer. And 6.5 is not an integer, and 6.8 is not an integer. So what we have to do is just a little work here. Oops, sorry. And convert these a little bit so we get a little bit more room. So let's take 5 divided by 6.8. And another little technique here to handle decimals is not always widely well known, but let me share it with you. Okay, 6.8 is not an integer. It's not a whole number, okay? So what you do to simply make it an integer, all right, is simply shift the decimal to the right. So we want to shift the decimal right place, or one place to the right. To do that is easy. We multiply it by 10/10. All right, that will shift the decimal place. So we get 50/68. If you reduce that, you get 25/34. On the second fraction, we have 6 divided by 6.5, same thing. We can do the same thing, or we can multiply by 2 as well. Either one will work. But let me just follow the same approach. You get creative. You don't have to use 10. Just 10 shifts the decimal. We know that. We know that from grade school, actually. So if we multiply that by 10/10, what do we get? We get 50/65. Again, you just shift decimal right one place, reduce it. You get 25 divided by, divide them both by 5. Okay, and you get 10/13. Okay, again, divide by 5. Divide by 5. Here I divided by 2 because they're even. Okay, last fraction is 5 divided by 6.2. That's not rational either. So just simply multiply it by 10 tenths. That will shift the decimal easily. Okay, and you get 50 divided by 62. Divide both of these by 2, you get 25/31. Okay, so again, I just divide by 2 to reduce. Okay, reduce fractiones. All right, so my three fractions that are between these two, let's highlight them here. Okay, it's 25/34, 10/13, 25/32. Okay, and notice, dun, 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 they're a little bit different than the ones up here. Okay, okay, so there are many different possibilities here, guys. There's not just one answer, not just two. Believe it or not, there's an infinite number of answers here. Okay, so that's the amazing part about it, because I could have been really creative here. I didn't have to choose 6.8 and 6.5 and 6.2. You could have chosen 6.9 or 6.7 or 6.6 or 6.1. All right, so there's an infinite number of answers possible here on this. That's one of those important things. So let's make a little note of that. There is n, not m, but n, infinite number of possible answers here. Which is pretty damn amazing. All right, all you have to do is use your creativity. Okay, so in this little prep here, we talked about how you can easily create common denominators like you were trained to do in 4th, 5th grade. All right, and create fractions that are between two given fractions pretty easily. In method 2, perhaps new to you, we use decimals, keeping the numerator constant this time as opposed to the previous example, and then change up the numerator using decimals, and then convert to rational. Okay, so this process right here, let me just put it in red here. This is converting to rational. Convert to rational form. Okay, by using some conversion factor. Okay, so you got to do that because again, rational form is an integer divided by an integer, not an integer divided by a decimal. So when I ask you to find rational numbers between the two given two, you have to make sure that the final results are in rational form. So after you use your decimal method here, you got to convert, which is pretty simple. You know how to reduce. That's like a common technique taught many years ago, and then you get the three results. Okay, and then you can try it on your own in activity 2C1. All right, so that's just a short little intro or summary of what to do, going back to basics here. And I will see you after you do activity 2C1. So give it your best shot in your group, and I will see you in my next activity. This is Mr. Aynesworth. Bye-bye.